Great. Good afternoon, everyone. My name is Neeraj Madan, and I'm a committee member at MLOps and also manage the data science practice at IBM. Today's panel is about how to fine-tune your LLMs and evaluate the performance. As we get started, you all can use the VOVA app to submit your questions while the panel is going on, so we can take some questions at the end. And briefly, because the topic is so interesting, I'll briefly introduce all the speakers and our moderator. The first one, Hien Liu. Hien is a senior engineering manager at DoorDash, leading the machine learning platform team. He's particularly passionate about the intersection between the big data and AI. He has authored a book, Beginning Apache Spark 3, and he's been an avid speaker in all the conferences, so you'll see him very often around. Second, we have Savin. He's a co-founder and CTO of Outerbounds, which is where the team is building the modern ML stack to accelerate the impact of data science. Previously, he was at Netflix, where he built an open-sourced meta full-stack framework for data science. Third, we have Shaun. Hi, Shaun. He's a global head of solution. He's a global head of solution architecture at Cohere. Cohere provides a cloud-agnostic LLM and doesn't need an introduction. And their CEO is a co-author of Attention is All You Need, which is one of the popular paper in LLM area. Then we have Meryem. Meryem is a recovering physicist and the co-founder of TitanML. TitanML is an NLP development platform that focuses on deployability of LLMs. With this, I'll hand over the panel discussion to you.
All right, thank you, Raj. Thanks everyone for joining this session about how to fine-tune your LLMs. It is an important topic for us to know a bit because nowadays some of the open source LLMs are more accessible now. And so that's why, also this is one of the questions that we have during our the conference committee discussions as well. So we want to bring on a group of experts in this area and share their perspective and views. The way we're going to go through this is essentially examining at a high level, quickly, what is fine-tuning? Why do we want to do it? When do we want to do it? And maybe some best practice around that. So that's kind of the order we're going. All right, just to level set at a high level. So, briefly describe what LLM fine-tuning is. And let's start with Shaun.
Hello. Since I run the solution architecture team, I like to, when I think about fine-tuning, because there's so many different definitions, I like to think about the problem first that it's solving. And I think as we get these very powerful models, fine-tuning is a way to narrow this massive world of knowledge down to a specific problem and also teaching the model how to perform on that domain or problem. And so if you think of the original or the foundational models that are trained on a ton of unsupervised, basically unlabeled data, and this is the very resource intensive component of it. The fine tuning is when you come in with that very high quality labeled data or some sort of feedback mechanism where you're teaching it, this is the right way to do things, or this, you're doing it the right way, or maybe do it a little like this, or whatever. So it's solving like more specific problems.
Makes sense, yeah. Savin, anything you want to add to that?
Yeah, I mean, echoing what Shaun just mentioned, if you think about fine-tuning just as a colloquial term, then of course, I mean, it implies that you have a model, that model can potentially be slow, it can be expensive, it can be unreliable, and how do you basically take that model and tune its parameters so that it's more usable? So of course, performance could be one angle, one dimension where you want to make more progress on a certain specific domain, and you want to make sure that the model performance goes up. So that's where many fine-tuning applications come in handy. Many times your model is too large, you want to prune it down. You can rely on fine-tuning techniques for that. Many times the model is just too expensive to query, and just like dealing with a smaller fine-tuned model can sort of like help with that. So I think currently in public discourse, of course, I mean, there are people on the stage who are way more experts in the LLM space who understand what fine-tuning is, but if you're on Twitter, if you're in social media, then there are like many different definitions float around. And I think it's important to sort of like level set that fine-tuning, unfortunately, happens to be one of those terms where different people will have different definitions, everybody will agree, as well as everybody will disagree at the same time, and that leads to interesting conversations like these.
Yeah. So yeah, this is pretty unique to working with LLMs. Like with classical ML models, you don't even think about doing this, right? So continue with that point, like in terms of when, okay? When is this necessary? Because that's one thing you want to figure out as you're building LLMs applications. But also highlight when might not be the best approach to do it. So Meryem, can you share?
It's a great question. It's something that I think a lot of people get very confused about. So there are two main times when people use fine-tuning. So one is to inject knowledge into your model. So my model that's trained by Meta might not know about my particular domain. So I might be trying to inject knowledge. That's when some people try and fine-tune. And another time when it's used is if I'm trying to get my output to look in a certain form. So for example, the evolution from GPT-3 to GPT 3.5 was like turning it into a chat variant. So teaching it to reply in terms of question answer or in terms of chat. So if we think about it in terms of using it as a way to inject knowledge and then as a way to get it to talk in the way that you want, respond in the way that you want. Now, fine-tuning is really hard, and it's also quite expensive, so I kind of think of it as the last resort for both of those instances. So when we're trying to inject knowledge, it's actually a pretty poor way of injecting knowledge because your knowledge changes, it'll hallucinate, it'll be lossy. So the first point of call, if I would need to inject knowledge, is to use some sort of RAG, which is retrieval augmented generation. It's way easier than fine-tuning, and it's always my first point of call. So if RAG doesn't work, then potentially fine-tune. And if I'm fine-tuning to get my outputs in a certain format, there are a bunch of techniques which are emerging, which are for controlled generation, where you can specify that your LLM should respond in a certain JSON format. That's also way easier to do than fine-tuning. So I say fine-tune if RAG doesn't work and controlled generation doesn't work and you have data, then you might want to fine-tune.
All right, those are three things to think about. But also, Meryem, continuing with that, in your experience, have you seen any projects that you've seen like fine-tuning can really help delivering the value or accuracies? So any specific example that you know of that you can share with the audience?
Yeah, of course. I mean, you just pointed out that a lot of people fine-tune if they're really cost sensitive or potentially latency sensitive. So we worked with a team that were using an LLM to do invoice extraction. And the initial model they had was fine and it was good enough. I think it was a rather large llama model. However, it was pretty expensive to run and the inference was very, very slow. So what they did is they invested the time to collect high quality fine-tuning data and managed to create a model, a T5 model that was 1 billion parameters, so I think an order of magnitude smaller, which performed essentially perfectly. So they had a much, much, much smaller model essentially doing the same task because they put in that time and effort to fine-tune. So if deployment concerns are an issue, then fine-tuning can be a really nice way to get a smaller model to perform much better.
All right, so also continue with that line of thought or examples. In terms of fine-tuning LLMs to address some of the challenges in niche use cases, Savin, any thoughts on that or experience on that side?
I mean, definitely we come across people who have access to very specific, very proprietary data. They want to engage with that. So imagine, if you have access to financial transaction records and you want your LLM to be able to interface with that, then that could be a specific way where you can do some sort of instruction tuning, style fine-tuning. I think to echo sort of like what Meryem mentioned, what we have seen quite often is that fine-tuning is great when you are trying to figure out how should a model behave or how should a model interact. Versus if you think about a solution like RAG, then that sort of like comes in handy when you want to introduce net new information into your LLM system. And I think one thing that's important here also is to think about LLMs as not just the model, but the overall system as well, and what are the characteristics of that system. And in many cases, what will then end up happening is that for many of these use cases, niche, broad, I'm pretty sure like organizations of all shapes and sizes, they'll end up using LLMs alongside other ML techniques in every single dimension. But fine-tuning, prompt engineering, RAGs, they will all cohabit longer term. It could very well be the case that there is one single problem, and even for that, you're introducing net new information through RAG, you're controlling how the model behaves or what is the style of model outputs through fine-tuning, and then you're also overlaying some bit of fancy prompt engineering to sort of like achieve the desired results. So that's where we are seeing more sophisticated organizations sort of like move towards. And I think that's sort of like, also the trend as well, that many of these niche cases, they basically serve as the canary in the coal mine. They educate all of us in terms of what are the patterns that sort of like work well. But I would say, Shaun, you end up working with a lot of customers, so you might have a better sense here.
Yeah, no, I agree. And just to build on that, I think if you think about where we're at in the innovation cycle, the first round of LLMs when they were coming out, it's really about that ChatGPT experience or whatever, where people were wowed by it. But there wasn't a ton of business value in that. When you go to organizations, there's low-hanging fruit like content writing and those sort of things, but businesses have their value trapped in their processes and their data, to your point. And so the way to get the data in is through retrieval augmented generation. And then the way to teach it proprietary processes could be through fine-tuning. And you can think of these as specialized agents that you're trying to build. Like if you're a health and life sciences company, your data is not going to be publicly facing. So these, no matter how big the model is, it's never, and your processes are not. So it's not going to understand anything you do internally facing. So you have to create that agent either through the context window, which is limited, or through fine-tuning with the data. So.
Yeah, interesting example that I've seen where people are trying to start with like prompt engineering. And they got to a point that what they put in the prompt cannot fit into the context. So then they start exploring fine-tuning. So it's an interesting example. But okay, so we talk about when and why. Now let's explore some of the challenges in fine-tuning. So in your experience, any of you, what are some like key challenges that you have seen or encountered while doing tuning? Some people say like fine-tuning is like model training, but it's not exactly the same. So can you share your perspective and insights on example that you have seen like of some of the key challenges?
I would say that from our experience, the biggest challenge has always been getting access to data. If you have access to good enough data, then the fine-tuning tools that are available make the fine-tuning process much, much easier. Like I know Outerbounds do a lot in this space. But getting access to the data is really, really key because garbage in, garbage out, the quality of the model that you get out is directly proportional to the amount of effort you put in collecting and labeling the right data for your use case. There's a lot of solutions out there nowadays, like synthetic data generation, although this sometimes works, sometimes doesn't. But getting access to highly accurate, well labeled proprietary data is by far the biggest challenge.
Yeah, I would agree, and I think that we've approached the problem with just assuming that we're not going to get access to it. And so what I think is important, not just us, but all the LLM companies, is getting the tools, bringing the tools and the models to the data and to the experts. Because even if they did give us the data, we're not the subject matter experts, so we can't transform the data. We can't, we don't know. It takes longer for us to learn that domain than it would be for us to give them the tools and for us to teach them how to use the tools.
To sort of like add on to it, I'll have a question for you, Hien. Like, why do you think, or like, what are the differences between fine-tuning and ML training? And I'll sort of like preface that with, if you think about any data-intensive activity, especially in the machine learning data science space, many of the concerns that exist in that world are also equally applicable in the fine-tuning universe, right? For example, data quality or data availability is a big concern It's the same concern on the machine learning side of the house. It's the same concern on the data science side of the house. If you're running an optimizer, you want to make sure that your data is very well calibrated, clean, and whatnot. Similarly, because you're running a whole amount of compute, you also want to make sure that you have access to compute. I mean, in this day and age, while H100s are a reality, getting access to one is really tricky. And of course, if you work in an organization, let's say you are a customer of one specific hyperscaler, and if they are not providing you availability, then you can't really get your work done. And that is a reality today. That reality is also applicable if you want to train a neural network on top of GPUs, right? So that sort of translates in many ways. I think another sort of interesting aspect around fine-tuning is that you can't just expect to fine-tune once, and what comes at the end of it is the final result. Just like model training, you have to experiment quite a bit to come up with different variants of the final model and see what works. And then once you have something that seems to work, you can't really stop there, right? Because at the end of the day, all of these models are in some way an interpretation, a manifestation of the reality as we perceive it. And that reality is also changing as time moves forward. So these models need to be kept up to date. There might be newer data that might be coming in. Business processes inside an organization might be changing, so the model may need to adapt. The data that's used to fine-tune, you may have fresher data, so you may need to re-fine-tune. So many of those concerns may still sort of come in, that people are still sort of working through around how to build better ML systems. And my hope is that, let's say if we project sort of 6 months out, then all of us will agree that fine-tuning and all of these other approaches, they are one other tool in our tool belt. And then at the end of the day, what we really need to figure out is what are the best ways to build these ML systems that will include these approaches, as well as many others that we are yet to discover.
Yeah, well, what was your question again?
Why would fine-tuning be different than ML training, or what would be the concerns?
Yeah, gotcha. I think you kind of answered it during what you brought up. I mean, there's a lot of similarities, definitely, in terms of the iteration, the experimentation, garbage in or garbage out. What's new is what you alluded to is the hardware that you need, right? The GPUs. And that's hard to come by, like you said, nowadays. I think that's one of the things that is different. I think the other dimension is the evaluation process of that as well, which we haven't touched on yet. So there are some similarities, but there are some differences, I believe. But talking about the cost factor, should be on everybody's mind, given that GPUs are not cheap. So as we go do about fine-tuning, what approaches, what techniques, in your experience, you can share to help with the cost factor? Let's start with Meryem.
Okay, I'll very briefly answer this. So they are expensive, they're getting cheaper. So the better the base model you start with, the less fine-tuning you have to do. And the base models are getting better and better by the day. There are also a bunch of techniques, like an example is Cohere, where you don't update the entire model, and the bits that you don't update, you store in a quantized form, so you can do that on much smaller hardware. So that's one way of approaching the fine-tuning problem. But the long and the short of it is that it is expensive. It's also, I know you have to do it multiple times, but more or less a one-off cost, and it does get amortized pretty quickly when you consider the fact that you can use a much smaller model and much shorter prompts. So the running cycle of your model in the long term does tend to be smaller as well. So the issue tends to not be cost, but actually just begging your AWS account manager to get access to enough GPUs seems to be the biggest bottleneck that we see.
I really agree on that front. I think one of the biggest way to save costs would be just getting deep discounts on your GPU purchases from your hyperscalers. I think that's the best bet. But you can imagine, the cost of training an LLM or fine-tuning LLMs was really sky high early this year, and that has gone down. And that is going to be the case going forward too. So many of these conversations that all of us are having around GPU availability and sort of sky high costs and many of these models not fitting into sort of any sizable instance type. I think these problems are also short-lived. I mean, these are real problems. They need to be solved today. But once a solution comes in, then I think we'll sort of look back at all of these conversations with sort of rather fond memory. I would say that, I mean, at the end of the day, there's sort of like a big human element to everything involved as well, right? So there's sort of like the machine cost, which is sort of like more in the engineering domain, but there's also the people cost. It is also a reality that now, because of GPT and large language models, a lot of organizations are looking at investing in machine learning for the very first time. And as you all might know, building an ML product, while in many ways similar to building a software product, is still very different. So the way you sort of like organize your teams, the way you organize your product management practices, they all need to substantially change in many ways. And that's sort of like in many ways the hidden cost that most organizations haven't really sort of like figured out how to deal with. That's why we are seeing many companies spinning up an innovation department or sort of like, a skunkworks project to embed intelligence through LLMs into their product. And the real win will come in when every single engineer, every single data scientist feels empowered to introduce this intelligence into their product. So how do we sort of like, make it a non-event, so to speak? I think that's going to be sort of like the biggest jump that will make in terms of reducing overall costs. It shouldn't be the case that introducing GenAI into your product should be limited to the most high visibility feature in your product. It should live and breathe in the smallest of business processes and the smallest of features that you ship out to your customers.
Cool, thank you for that. Shaun, anything you want to add on a cost factor?
I would say understanding the problem, decompose it down into as small of atomic problems as possible, and then start with a smaller model to get your data pipeline down, your process going, move the needle there, and then only then, when you haven't solved the problem with that, move to bigger models, because you could be looking at 1/10 of the cost to do 95% of your steps, as opposed to full price to do 100% of the steps.
I'm also going to add something on the cost element from my first answer, which is only do fine-tuning if RAG and controlled generation doesn't work, because you will probably find for 80 to 90% of enterprise use cases, you don't even need to fine-tune. The open source language models are good enough, and that makes it much, much cheaper.
Just want to add one more tidbit on that. The cost factor depends how many teams inside your company are trying to do fine-tuning. If there's 1 or 2 team members, not a problem. Just want to share a tidbit about what we do at DoorDash is we actually have a process for requesting for GPUs, and we have cost attributions on top of the GPUs. So it depends. So, all right, so let's move on to the next step, which you kind of talked a little bit about, Savin, is the people involved or the collaboration among the different teams in the fine-tuning process. Data scientists, machine learning engineers, and ML platform engineers and such. Any recommendation in terms of how to ensure a smooth fine-tuning process, or how do these teams will want to work together on the fine-tuning process? Yeah, let's start with you, and then we go to Shaun after that.
Okay, all right. So I'm a big proponent of reactive ML systems. Now, especially if you're in a large organization, then it's very likely that the system that you're building will have many stakeholders split across different teams, often different organizations, and you need a clear way to do a handoff, right? So imagine sort of like a hypothetical scenario, which might not be super hypothetical either, where you have a data engineering team that's responsible for curating some data set. Maybe that data set is used for your fine-tuning data set, or maybe sort of like, that feeds into the prompts that you use. Then you have 1 or more data science teams that are responsible for training these models, fine-tuning these models. You may have downstream consumers of these models that could again be other data science teams, or these could be other product teams. And now one big issue that sort of like bites most organizations is that it's oftentimes, while still non-trivial, it's still a bit feasible to set up all of these systems once. But as soon as you start tweaking certain things, maybe you have new data, maybe you want to fine-tune again, maybe you want to change certain hyperparameters for your fine-tuning workloads, that feasibly sort of like changes the outcome of your models, changes the data in meaningful ways. How do you signal to other teams, right? How does sort of like an organization work together as part of a larger machine learning system, and they are all contributing to various components of that machine learning system? That's really important. And our sort of like recommendation always has been that any activity that happens in any given team, they should be basically publishing, let's say, events that encode what is it that the team has done, what changes have been shipped, and then other teams can basically listen into those events and then basically configure their systems to react to those changes, to those updates. And if you sort of like set up the system, then that sort of like helps in better handoffs, helps in better lineage tracking as well, because those are also things that really need to be taken care of, that when things fail, first you need to figure out how to recover from those failures easily, then you need to figure out what's the root cause of that failure, how do you address it, and that problem gets multiplied if you're working across multiple stakeholders. So these sort of like contracts of sorts that are in many ways event-driven are really helpful at times.
Cool. Shaun, you want to add to that?
Yeah, I would say that if you're thinking of this like a product, you should have someone that understands the user and really, because these are non-deterministic models, so like you said, event tracking, like the ability to capture all the changes you're making, plus model changes, you have to have all those pieces in place, but it's helpful to remember that no matter whatever metrics you capture, the feedback from the user is really the true north and the ground truth on most of, at least with the language stuff that we're dealing with. The majority of the time, that's the signal that's the toughest to capture because humans change their mind a lot and of what's good and what's bad. And so putting all the tools in place to even capture when they're changing their minds. And so, yeah, the feedback mechanism's super important.
Makes sense. All right, time flies. We're on to the last question, and this is a fun and exciting one. The future, forward-looking. Looking into your, I forgot a term, but what do you see as emergent trends or advancements in this area in the Finetune that you're excited about, that you might want to bring attention to the audience here in the room? Let's start with Meryem.
I think my controversial take, and I promised you a controversial take earlier, is that I think fine-tuning will become less important over the next couple of years. I think within a couple of years we won't be speaking about it as much.
Okay.
For a couple of reasons. Firstly, the base models will become so good. The open source ones especially will become so good that prompt engineering will be able to do a lot of it. We're going to perfect RAG. Like RAG has only really been in production for like 6 months, so we're really going to get better at that. And thirdly, I'm really excited by control generation. So how can we force our model to answer in the way we want it to answer, in terms of format, not answer, without actually changing the model architecture itself? And all three of those are progressing at enormous pace. And I think fine-tuning will be a minority of enterprise applications.
Fascinating. I believe this session is being recorded, so we're going to watch this session in about 2 years from now. Savin, what's your take?
I kind of agree with Meryem here that I think we are sort of like at the very early innings of what's possible with customizing models. We are going to see many approaches. It could still be the case that number of organizations who are fine-tuning and the number of fine-tuned models, that continues to explode, but overall as a fraction of activities around LLMs, that can definitely sort of like settle into a minority as we sort of like come across better models, better hardware, better expectations around what these models can do.
Shaun.
I would say that the applications that are coming off of these are going to be more robust and more, if the first part of the cycle was these foundational models getting stronger, like the next cycle will be the killer applications coming out as the models improve and get smaller and cheaper and those type of things. So.
Yep. This is definitely an exciting area and evolving very, very rapidly. So we'll see what's going to happen in the next 6 months or 2 years. We have about a minute left, so if there are questions for the panel, feel free to raise your hand and we'll have some mic running to you. Oh. There are 3. Okay, let's pick one. Okay. I'll pick the last one. What kind of horizontal scaling would you suggest for optimal performance for fine-tune Llama to 13B or 7B? Very specific question here.
I think you should come speak to me after the session.
All right, that's an easy one. Okay, maybe we can speak about this. Okay, how would you educate subject matter experts in using fine-tuning tools?
I think that we have to make the tools easier to use. These are subject matter experts in their domains. We shouldn't expect them to be subject matter experts in ours. So make the tools easier to use.
All right. So make it easier, and then they don't have to read instructions. Okay, last one. I'm teaching a Vicuna 13B model SQL queries using Puff and LoRa. Would it be better to spoon feed it using smaller data sets into one? Oh, sorry. If I feed a smaller data set or just combine all the data set into one and fine tune it?
Depends on what you are trying to achieve here, but again, happy to chat offline about this. So I guess that's my pitch for people showing up at the Outerbounds booth.
All right, with that, we at time. So appreciate everyone for attending this session, and thanks to the panelists.